Uh, Good afternoon once more, everyone. As I've indicated, my name is Mr. Mufkeng, the subject advisor, Maths Grade 8 and 9. Today, I'm going to do surface area of right prisms with special focus to the cylinder. Let me indicate that a cylinder is one prism that is introduced in grade 9. All other prisms that we did were introduced in grade 8. So we will have to look into how to develop the formula to calculate the surface area of right prism. Right. As I've indicated, surface area of a cylinder. The surface area, I want to start here most of the time. The surface area of a right prism is the sum of the areas of each individual face that makes up the surface of the prism. I want to repeat this. The surface area of a right prism is the sum of the areas of each individual face that makes up the face, the surface of the prism. Like for instance, if we look into the one that we did before this one, the one of a triangular prism, I indicated that triangular prism is having 5 faces, of which 2 of them are identical and are triangles. So in this case, we will have to look into how are the faces are. Again, I want to reiterate again the issue of what a prism is. A prism is a 3D shape with two identical and parallel faces at the opposite ends. So each and every prism will have two faces that are identical, that are parallel. These faces are known as the basis of the prisms. They are the basis of the prisms. They are in such a way that when you move or you cross-section that particular prism, you will get the same shape. It will not change the shape. So the faces are known as the basis of the prisms. Right. If these two faces are cycles, the right prism is a cylinder. As I'm saying, we are just going to talk about the cylinder. The two faces are cycles. The right prism is a cylinder. Which two faces? Those faces that form the basis of the prism. If they are cycles, then the prism is a cylinder. Right. Here we are having these two faces that are cycles, and then they complete part of a cylinder. So what we are seeing now, we are actually seeing a cylinder. We are actually seeing a cylinder with two faces that are parallel and that are identical. And these faces are cycles. Right. Now we are just going to explain again the issue of a height. A height is actually created when we move the base to create a prism. We actually move the base such that we create a prism, and by so doing, then we create a height. So in this case, the height of the cylinder is determined by moving its base. And then as you can see there, the base in that color, not the green one, in orange color. And then we are just going to show how do the base is moved in order to create a height. There we go. This is how the height of the prism is created. So in other words, the base is moving a particular height to have the cylinder. Right. And then moving forward, we are now going to engage in formulating the formula to calculate the surface area of a cylinder. This is the cylinder with 2 cycles and its height. Right. The cylinder has 3 faces. It has 3 faces. The first 2 faces are the 2 cycles that are identical. The 2 faces that are identical, which are the cycles. And for us to calculate the area of these faces, we must know the area, how to calculate the area of a cycle. And the area of a cycle is calculated by pi r squared. So that means in here we are having the area, 2 areas of pi r squared. We are having 2 areas of pi r squared. So we are left with 1 face. So the 1 face is the curved rectangle. The 1 face is a curved rectangle. This curved rectangle, it is in such a way that when you cross section again, and then you take that part of a curved rectangle, it actually forms a rectangle. You will be seeing basically a rectangle. Right. So to demonstrate that, you can even take this part of a tissue paper, and then you just cut it through, and then you open it. It will show you a rectangle. So in this case, we are having the curved rectangle. So in other words, we are now having 3 faces. For a curved rectangle, remember, to calculate the area of a rectangle, we're saying it's a length times breadth. But in this case, the length of the curved rectangle will be in the form of a cycle. And if we check that cycle, it will be a circumference of the cycles. Circumference of a cycle will be the length of the curved rectangle. I've even indicated here, this is the length of the rectangle, and then it will be in the form of the circumference of the cycle. So in order to calculate the circumference of the cycle, you will have 2 pi r. So this length will be 2 pi r. And then again, we will have to have the height of this curved rectangle as our breadth. Therefore, we are now having the length. We are also having the breadth. And then it will be easier for us to calculate the area of the curved rectangle. So in other words, this is what you'll see basically after opening that curved rectangle. You will see exactly the rectangle, but the length of the rectangle, as I've alluded, it is the length of the circumference of a cycle, and the circumference of the cycle is 2 pi r. Therefore, the length will give us 2 pi r. And what will be the breadth? The breadth will be our height. The breadth will be our height. So it shows that now we can be able to calculate the area of the curved rectangle. And this will be when we multiply the length, which is 2 pi r, by the breadth, which is our height, and we get 2 pi r h. This will be the area of the curved rectangle. So now we will have to add this together to have the formula to calculate the surface area of a cylinder. So here we go. This is the surface area, which is equivalent to pi r squared plus pi r squared. That simply means it is the areas of these two cycles. And then adding to that, it will be the area of the curved cycle, which is 2 pi r h. And then if we add the like terms, we will have 2 pi r squared plus 2 pi r h. So the 2 pi r, the pi r squared, the 2 pi r squared, when they added together, it will be 2 pi r squared. All right. So this mark the formula to calculate the surface area of the cylinder. So let's have a look at one example at least. Calculate the surface area of a cylinder below. The radius of the cylinder is 7 centimeters and the height of the cylinder is 15 centimeters. Use the value of pi as 3.142. Right, here is the cylinder described in the statement with the diameter of 7 centimeters and the height of 15 centimeters. So we have to calculate the surface area. So for us to calculate the surface area, we must have the formula. The formula says a surface area of a cylinder is 2 pi r squared plus 2 pi r h. Now we are going to substitute from this formula. For pi, we substitute 3,142. And then for radius, it is given as 7 and so forth, even this side. And then ultimately, we are having this as 307,916, 307,916, as well as 659,82. Then added together, they will give us a surface area of 967,736. Right. In the previous presentation, I indicated that it is better to use only the values when you are calculating. But at the end, you must have the units. The reason being there are learners who are actually substituting, instead of substituting 7 centimeter or squared, they will substitute 7 centimeter squared, and it changes the meaning, and ultimately they lose the marks. So the best way to remedy that is to ensure that we don't use the units during the calculations, but we indicate the units on the final answer. Thank you for tuning in for today's lesson and wish you well through your examination. Thank you very much.